Himss 2014. Here with Eric Bruno.
All right, so what we're showing here is a connected health demo where we have a patient who has some kind of chronic disease. In our particular scenario, that chronic disease is heart failure. It could be any type of disease that the patient may have. That's our specific scenario. This patient has some remotely monitored devices that they take readings from at home according to their doctor's instruction. They have a home health hub which reads data from these devices and transmits that wirelessly to the healthcare provider through a backend the healthcare provider can actually get to from a back end, similar to this dash link we'll look at. In this case, this is our home health gateway. In reality, it will be much smaller, but this is just our development box here. And the way that this is set up is we have on this home health gateway connected to a router in the home. We have Java embedded with an embedded event processor running, a complex event processor, which is analyzing the data coming from these devices in real time and doing some local analytics to determine the state of that patient's health without concern for whether the doctor is actually watching at that time or not. So it can detect, looking at the correlation of the data readings from these devices, aggregating them together, going over certain analytics locally that are personalized for that patient. It can detect whether that patient, in our case, is actually about to have heart failure before maybe the doctor even gets a chance to see it. This helps in scenarios where the doctor is inundated with data from all sorts of devices in a situation that can cause what's called alarm fatigue. So this will actually generate a very specific alert by taking this data, analyzing it locally, and determining that there is something going on without worry about all this data being sent and analyzed remotely. The patient will be presented with a local tablet with a user interface. In this case, it's a Java-based user interface. It's communicating with our gateway. Again, there's a Java embedded application running on there and a complex event processor. This screen here is something that the healthcare provider would have access to in the back end. And it actually gives a view of multiple patients. But we'll show what happens as we take readings here locally. So I'm going to connect this to show a live data reading, and then we'll go through a scenario where the patient is actually having heart failure with simulated data. But I'll show the live data first. To actually take a live reading, I'm going to use a pulse oximeter since it's an easy device to work with. This pulse oximeter is communicating over a continuous compliant Bluetooth stack running in Java on our home health gateway, so the patient doesn't have to worry about things being plugged in. So it's taking my reading right now. And as soon as it's done, I will take a look at the user interface and see that it updated with my reading. So it should be 98 over 85. And there you go. You can see the 98 for oxygen and 85 for heart rate. So now what I'm going to do is show a scenario where our patient is having heart failure or about to have heart failure. To do that, we have to actually simulate the data from these readings. We're going to simulate data being read by a patient 4 times a day. They're taking readings 4 times a day. Blood pressure, weight, and pulse oximeter. Now, if the pulse over the course of a few days for this patient goes up a little bit, it's not a big deal. If the weight increases a little bit, everyone's weight fluctuates, not a big deal. If their blood pressure increases over the course of a couple of days, again, not a big deal alone. But all those 3 factors increase by a certain percentage together over, if you keep the running average over 2 to 3 days, that could indicate heart failure. It could actually be a very serious scenario for this patient. So what we're going to do is actually simulate that with our event processor analyzing all 3 feeds in real time throughout each day, averaging out the readings and keeping a running average throughout the week to see if the scenario occurs for this patient. Now, these rules are able to be personalized for each patient according to whatever their particular situation is. So I'm going to take the user interface here, take it out of live mode, and put it into simulated mode. I'm going to bring up the same interface we saw before, but now we actually see, just for our demonstration purposes, a little box here, and that's going to show our simulated device readings. I'm not actually going to take device readings because I'm not actually going to have heart failure, I think, here today. So I'm going to start out with a baseline. And our patient has a baseline of 140 over 70 for blood pressure, 90 for oxygenation, 77 for heart rate, and a weight of 200 pounds. Just an example scenario for a baseline for this patient. Let's take the first day of readings. I'll click the button here, and it just simulated 4 readings for the first day, and really all that happened was the weight increased just a little bit for this patient. Not a big deal. Again, this is something that the doctor can get access to in the back end, but perhaps he won't have access to it in real time, and that's the value of our analytics running here. After day 2, we see that the blood pressure has increased just slightly, everything else has pretty much stayed the same compared to the day before. Again, not a problem. By day 3, the weight has increased another pound or 2. The heart rate has increased as well. Simulate day 4 readings, 4 readings per day again, and we see the weight has yet gone up again. Pulse rate has gone up, and blood pressure has slightly elevated. By day 5 in our sample data, what has happened is each of these values over the course of 2 to 3 days has increased a certain percentage. Again, the doctor has programmed that to trigger our healthcare event. And what has happened here is that the system running here locally to the patient has detected that there's a potential for heart failure. This patient may be suffering from acute heart failure. So in their local tablet, they'll actually be presented with an interface, and they'll be asked how they feel. And it'll be very simple. All they have to do is choose a smiley face if they're feeling fine, a sad face if they're not feeling well at all, or a so-so face meaning I'm okay but not great. And they can also provide some optional feedback. So I'll just do that. I'll select the so-so face, and I'll type in that I'm feeling sluggish, which is consistent with the patient having heart failure. And that patient can send that data off, which actually goes to the back end for the healthcare provider to see. Whether or not the user actually does that, still the alert will be sent to the back end. And what we're showing basically is that we've got the data coming from our local devices from the patient being analyzed locally, so we don't have to worry about all this data inundating the healthcare provider to make an analysis in a life and death situation. But I want to show you now what the doctor will see. Obviously, the doctor will be able to have access to this patient's data and can actually pinpoint different readings from the devices as they come in real time. So you have the blood pressure data, we have pulse oximeter data. If I were to scroll down, you'll see that as well. It actually charts it over time, so the same analytics we had running here locally are being charted here in this patient dashboard. And I'm just going to switch over here. The most important part here is that the healthcare provider will notice he has some alerts. We've run this a few times today, so you can see that we have a few alerts. But the most important thing here is that we have that last set of data that we have right here comes up that we have a heart failure detected for this patient. Patients are identified by ID here for privacy, but that's the important part. So we have an end-to-end scenario. We have devices that are reading data at the monitoring patient, analytics running at the home, and being all transmitted back to a back end that the healthcare provider has access to.